In this course, you'll learn a lot about JavaScript. Now, what if I were to tell you that there is another programming language closely related to JavaScript, which is also worth knowing, and that is TypeScript. Now, don't worry, it's not a brand new language you have to learn. Instead, TypeScript is a language which does not run in browsers, which does not run in Node.js, so it's not like JavaScript when it comes to that, but instead it's a language which builds up on JavaScript, which has to be compiled down to JavaScript with help of a tool which we're going to install, and which adds new features to JavaScript to make JavaScript development easier, maybe more fun, but definitely also cleaner, and helps you write cleaner code. So in this module, we'll have a look at what exactly TypeScript is and how it works, how you can use it, and how it looks like. And you will then also see why you might want to use it, how to write TypeScript code, that it's not that different compared to JavaScript, and how you can utilize it for your projects. So what exactly is TypeScript? That's important to understand, right? Because without knowing that, it will be hard to learn it and to use it. Now, it's important to understand, and I really want to stress this, that TypeScript is not a brand new language with a totally different syntax. No, it builds up on JavaScript. It is a so-called superset to JavaScript, which in the end means it is JavaScript, but it adds more features, more syntax features you can use. Now, it is worth noting, as I mentioned, that TypeScript does not run in browsers. Browsers don't know how to execute TypeScript. They know how to execute JavaScript. So whilst you will learn how to write TypeScript in this module here, it's not a language you can use like this in browsers. Instead, and that's of course also something you'll learn in this module, we need an extra tool which compiles TypeScript code to JavaScript code, so which converts the code to JavaScript, so that we have the JavaScript code we learn about, but during development, when we write TypeScript code, we have a better experience because of all these extra features. Now, speaking of that, which features does TypeScript add? Well, most importantly, the thing that gives TypeScript its name. It adds types. And with that, I mean data types. Now, of course, in JavaScript, we also know types. You learned about the core types JavaScript has: strings, numbers, booleans, objects, and so on. Now, it is important to understand that JavaScript is a dynamic, weakly typed language, which means that types are evaluated during runtime, so when your script executes, but they're not something you define when you write your code. Of course, you might know that here you're working with a string and in another place you're working with a number, but you're not putting that into your code. And let me give you an example where this might matter. Consider this simple add function which adds two numbers, presumably at least. But now let's say you're calling this function with two strings which you're passing in. Please notice the quotes around the numbers. Now, of course, you might wonder why you would do that, but consider that this is coming from an input field in your DOM, in your web page. What you get from there will always be a string. So even if the user enters a number there, it technically will be a string. Now, if you add these two strings here, you will actually find a bug in your application. It will not crash or show an error, but what you will get is basically the concatenated strings. And I can quickly show this to you here in the normal JavaScript console in a browser. If I add 5 plus 3, we get 53 as a string because it simply concatenates those instead of adding them. Now that's probably undesired. And in TypeScript, you can avoid this because in TypeScript you can add types. And this is now a syntax feature which is added by TypeScript, which does not exist in JavaScript. Notice the colons after A and B in the parameter list of the function, and after the colon you see the word number. This is TypeScript syntax, which in the end tells TypeScript that both A and B in this case here should be of type number. So we must only call this function with two numbers being fed in, not with two strings. So here in TypeScript, when we compile this to JavaScript, I mentioned that it needs to be compiled, we will get a compile time error, giving us as a developer a chance of fixing this before we even test it in the browser. So we can catch errors or bugs like this way earlier. And that's the huge thing about TypeScript, or one of the huge things. Now, besides adding types, TypeScript also adds some other nice features which don't exist like this in JavaScript. Of course, these features, since TypeScript doesn't run in browsers, are always compiled down to JavaScript workarounds to make the same feature work there as well. But in TypeScript, it's often easier to implement certain things thanks to these extra features. And in addition, TypeScript also compiles next generation JavaScript code to old generation JavaScript code, you could say. So the thing Babel does, the tool we learned about in the browser support module, TypeScript actually has this built in. TypeScript also allows you to write modern JavaScript TypeScript code in the TypeScript files, and as a result get JavaScript files which will run in older browsers as well. So TypeScript sounds pretty interesting to me. Let's take a closer look at it. Let's see how we install that compiler, and let's write some TypeScript code. So in order to get started with TypeScript, we have to install this TypeScript compiler, because I explained that TypeScript doesn't run like this as a language in a browser. Instead, the browser understands JavaScript, so we need this compiler, this tool, which takes our TypeScript code and converts it to JavaScript code. Now for that, you can visit typescriptlang.org. And on this page, you'll find a download link. This is the official page of the TypeScript project, by the way. So there you also find the official docs if you want to dive into those. But for the moment, we can click on download here to learn how to install this compiler. And here we actually don't have a download link. Instead, we install this TypeScript tool with npm, so with the Node Package Manager. Now, we already used this before in the course, but in case you somehow skipped those sections, you get this tool as a command you can use in your terminal or command prompt once you install Node.js. So for that, you can visit nodejs.org, and there simply download and install that latest version. With this button you download it, you get an installer, you can walk through the installer, and you can install Node.js on your system. Now, Node.js is a runtime for JavaScript, and this gets used by the compiler behind the scenes. But most importantly, if you install Node.js, you also install the Node Package Manager, a tool which actually allows you to, well, install packages, for example, global packages, global tools, like this TypeScript tool. So with Node.js installed, you can open up your system command prompt or terminal, and there simply run npm install -g for global TypeScript. This will install this tool globally. Now on Mac and Linux, you might need to add a sudo in front of this to get the right permissions. Once this installation finishes, you got TypeScript, this compiler installed, and you're ready to write some TypeScript code. Now to do that, let's head over to a new project, and here I essentially got an empty folder opened up in Visual Studio Code, which is the IDE I'm using here. The two files and folders you see here are only configuration files, which you can ignore and which you don't need. And in there we can now add our first TypeScript file, for example, app.ts. The name is totally up to you. Now .ts is important. This stands for TypeScript, and this, well, simply is the extension we use here to make clear that we write some TypeScript code in there. Now, in this TypeScript file here, you can write TypeScript code, and it's important to understand here that TypeScript, as I mentioned, builds up on JavaScript. So generally, you can write normal JavaScript code in here. And indeed, any JavaScript code works in a TypeScript file, but you can then also add certain features which only work in TypeScript. So it's JavaScript plus, so to say. Now, what can we do in here? Well, we can, for example, add a function, add, where we get two parameters, a and b, and where we return a plus b. That's the example from the slide I showed earlier. Now let's create a result constant here and call add, and pass in 5 and let's say 3 as strings. This was the example where we might get an unexpected result. We can console log result here, and now we can execute this. Now, to execute this, one way is to simply add an index.html file, And if you are using Visual Studio Code, you can then just type HTML here. You get these auto suggestions. And if you hit tab here, you get this HTML5 skeleton, where I'll just set a title of TypeScript, and where I will now add a script import. Now important, here we don't import app.ts but app.js, because as I mentioned, the browser won't be able to run our TypeScript code anyways. Now of course, we have no app.js file right now, but that will soon change. Now I will add defer here to make sure that the script gets downloaded early, but only executes once the entire DOM has been rendered. And with that, that's it. For the moment, I need no content in here, because in the script we got some code which runs automatically anyways and which simply prints this result. Now, the app.js file is missing, as I mentioned, right? Now with the help of the TypeScript compiler, we can get this. All we need is a new terminal, and here I will use the built-in one. So your normal command prompt or terminal, simply navigate it into this project folder, and there, since we installed TypeScript with this command, we can now run tsc. This is a command which is now available thanks to the globally installed TypeScript compiler, app.ts. And what this command does is it takes this app.ts file and converts it into a JavaScript file, converting any TypeScript specific code into JavaScript code. And of course, running all that TypeScript logic, checking for all these types and so on. And right now, please note that in here we have absolutely no TypeScript specific logic. This is all regular JavaScript code, but as I mentioned, we can write this in TypeScript files, and therefore this will also compile. So if I hit enter here, you see this completes, and now we get this app.js file. And if we have a look at this file, we see it's generally the same content. White space was removed, and you also see that const was translated to var. Because, and I did mention this, TypeScript also converts code to code that runs in older browsers as well. This is an extra benefit we get. So this is actually JavaScript code which also runs in older browsers. Later I will show you how you can tweak the configuration to make sure that it works according to your plans, and you, for example, keep const here if you want to. But for the moment, this is fine. As long as I have this file open, I also get some errors here in app.ts because my IDE thinks that all these functions and constants are now declared twice. To get rid of this, we simply close app.js and the errors are gone. These are not real errors. So we got the app.js file. Now let's simply open index.html. And for that, we can simply open it up in the Mac Finder or Windows Explorer and click twice on it. If you do that, a new tab should open up in your browser, and this will be an empty page, of course, because we have no content on our page, no content in the DOM. But if we open up the developer tools, we should see some output here, and we should see, in my case here, 53. Now that's of course not the result of 5 plus 3, but please note that I passed in 2 strings, and therefore if you add 2 strings, JavaScript concatenates them. It does not add them mathematically, it concatenates them. And that's the bug I mentioned on the slide. Now how can TypeScript help us with that? Well, in TypeScript, so in the TS file, we shouldn't work in the JS file because this is generated automatically when we compile. So in the TS file, we can now add some TypeScript features, the reason why we use TypeScript. We can add a type assignment here, for example, on the parameters. We can make it clear to the TypeScript compiler that A should be a number and B should be a number. We do that by adding a colon after the parameter where we want to assign a type, and then we write the type name. And there, for example, number is one of the types TypeScript supports. We do this after both A and B. So now what we're telling to TypeScript and to the TypeScript compiler is that both A and B should be of type number. And you see in my IDE, I now automatically get an error here because Visual Studio Code, the IDE I'm using here, is actually an IDE with built-in TypeScript support, and therefore it automatically parses my code and detects that I'm violating my type rules here. So it gives me an error here. Now, even if you're not getting this in the IDE, you'll see we now get an error if I try to compile this file again by again running tsc app.ts. You see now down there, we actually get an error that the argument of type 5, which is wrapped in quotes, so which is of type string, is not assignable to a parameter of type number. And it also shows us which line violates our rule. This is TypeScript in action. This is one of the main reasons why we use TypeScript. Now I'm very specific about the types of data I want to work with here. And I avoid mistakes like this one here, where I pass the wrong type of data into this function. Now, of course, since we call the function here on our own, it might be unlikely that we pass in string data like this. But imagine we're actually gathering input from a user input field in the DOM. Values we get from there would always be a string by default, and we might have forgotten to convert them. In that case, TypeScript can help us tremendously, because it shows us such an error before we even run our code and we have to find the bug there. Now we get an error during compilation. Now it still compiles the code, it still generates the app.js file, but it warns us here, it gives us this error, and now we can go ahead and fix this error by passing in values of the correct type. And now if I try to compile this again, it compiles without errors, and in the running application, if we reload, we got rid of this bug. So this is how TypeScript can help us write cleaner code and avoid unnecessary mistakes, simply by adding some types here. Now that's not all you can do in TypeScript, and not the only way of working with types, but it is an important start. Now let's see how else we can work with types in TypeScript. So we got our hands dirty with TypeScript, and we see why TypeScript might be helpful. We also already learned about the first type TypeScript supports, and that's the number type, and how we can assign this type to, in this case, a parameter. Now before we dive into other types, let me also make it clear how else you can work with types in TypeScript. Here we are assigning a type. We are actively telling TypeScript, hey, this parameter is of type number. Now, actually, in this snippet here, types are also getting used in other places. For example, in this line here, which type does result have? We don't assign a type here, right? We have no colon after this. Well, turns out that we don't need to. We can actually add one and make it clear that result will also hold a number. Of course it will, because we return the addition of two numbers here. But we don't have to do that. We can do that, but it's not necessary, because TypeScript has a built-in feature which is called type inference, which means TypeScript is really doing its best, and it is really smart, about inferring types you're working with. And in this case, if I hover over result here in Visual Studio Code, I see that TypeScript inferred that this is of type number. Now, how did it do that? Well, it actually also inferred the return type of the add function. If I hover over add here, you see this is basically the type of this function. You see the two parameter types here, and then after the function as a whole, you also see a colon, and then here also the type number. Now that basically is what TypeScript inferred to be the return type of this function. So TypeScript correctly infers that since we add a and b in here and return the result, and a and b are numbers, we have a return type of type number. Well, and since we store the returned value of the add function in result, TypeScript also infers that result holds a number. So type inference is really a key feature of TypeScript as well. And it is a good practice to not unnecessarily reassign a type. TypeScript could infer anyways. It's also not a bad mistake, but it's simply not required. TypeScript already knows which type we have here. And side note, if I now were to assign another type, for example string, which TypeScript also supports, I of course get an error, because I'm actually storing a number in a constant which I defined to hold a string. So if I wanted to store a string in here, then indeed I now need to fix something about my code. I either need to return a string here, for example by wrapping this into parentheses and calling toString here, or instead of doing that, of course, we also could call toString here. So that is something we can do, but here I will get rid of it and I will use this type inference because I'm fine with using a number here. Now speaking of numbers, which other types do we have? We just saw the string, right? I assigned the type string here. So string is another core type TypeScript supports. And in general, it supports all the core types JavaScript knows as well. Numbers, strings, booleans, objects, and so on. So this is the string. If we wanted to work with a Boolean like is done, well, then here TypeScript would infer that is done holds a Boolean. Actually, it infers here that it holds exactly false, and I'll come back to these exact types later. But we can also accept any Boolean here. And if I would turn this into a variable here, where we can assign a new value, then TypeScript also infers that this is a Boolean, and it would allow us to assign true as a value as well. Just for a constant, it inferred the concrete type false, because constants can't get new values, so there TypeScript knows that it's not even a Boolean, it's really just false. For a variable, it is a Boolean. So Booleans, strings, numbers, we have all these types. Makes sense, I guess. Which other types do we have? Well, we also have function types. And with that, I don't mean the types of the parameters, I really mean the type of the function as a whole. So a type that describes the entire function. What do I mean by that? Well, if we hover over it, we see the function type. This is how the function type in the end is inferred. The function type includes both the parameters as well as the return value. And we can of course also set our own return value here by adding a colon after the parameter list and then defining our return type. And here again, if I set this to type string, then of course my current logic in a function is not correct, because this will return just the result of two numbers being added together, which is a number, so I would not meet my function type here. So we might want to get rid of that and use type inference or change our logic. So the function is made up of the parameter types and the return type. Now when it comes to the return type, you can also of course have functions that don't return anything. For example, print result. Let's say this is a function which takes a result, and there I console log the result, like this. Now if I use this function down there to print the, well, result I got here, you see this will work, but now of course this function doesn't return anything. We can make clear that this function won't return anything by adding a return type of void here. Now that's a type added by TypeScript, and this basically means this function has no return statement. We could also go with undefined here. Undefined is also a valid type in TypeScript, but as you see, I'm now getting an error. Why? Well, technically a function that doesn't return anything returns undefined in JavaScript. But in TypeScript, there is a slight differentiation between these cases. If I set the return type of a function to undefined, TypeScript would expect that I have a return value, which simply is undefined. If I don't intend on returning anything, then technically still if I would use the return value, I would have undefined, but then in TypeScript, I should set this to void to make my intention clear. My intention is to not even have a return statement. And we do make this clear by setting this to void here. If I now would return undefined here, I also could do that, but the better practice is to now not return anything. Now, just as before, however, TypeScript infers that I don't return anything, so we don't need to add the return type of void here. If we don't add it, then TypeScript correctly infers that the return type is void. And you also see one other important type here, the any type. You see that for result, I didn't assign my own type. Now, of course, TypeScript can't infer the type of result because we just defined a function here. It is as if we would create a variable a here. How would TypeScript know what we plan on storing in there? How does TypeScript know what we plan on receiving here? It's not inferring the type by how we call the function later, so it can't infer the type here. In such a case, the type by default is any. And of course, we can also explicitly set the type to any here if we want to. Now, you should use the any type carefully though. It's kind of the last resort type you have in TypeScript. This is basically the default for all values if you don't work with types at all. And therefore, you give up all the advantages TypeScript offers. Because any, well, really works with any value. So the advantage you get by being explicit about your types and the advantage of being able to catch errors early, that is all lost if you work with the any type, because of course with that, TypeScript accepts any values. If on the other hand I make it clear that I want a number here, then I really only can pass a number into print result. And if I would pass in anything else, a string, a boolean, whatever, then it would fail. So sometimes it's fine to use the AnyType, but you should be careful about that. Here, I will leave it like this for the moment. Now, before we move on, let me also show you another way of working with types and how you can override type inference by TypeScript. To give you an example, let's say in the index.html file, we actually have two input fields. An input field with an ID of, let's say, num1, and then one with num2, and then we also have a button. And when we click this button, I want to trigger my add function here. So now we got these two inputs and the button. Now, of course, we need to get access to those inputs and the button in order to work with them and in order to read the values from there and add an event listener. So at the very top of the file, we could add a constant here, num1 input, and use document getElementById, and use the ID num1 here to get access to this element in the DOM. Now, num1 simply is the ID I assigned here. The other input has the ID num2. Hence, we can duplicate this to get the num2 input by that ID, and also get access to the button element with document query selector button. We only have one button on the page, so we can select it with this query selector. Now, with all that, I will actually comment out this code here at the bottom because we don't need it right now. And instead, I'll use the button element to add an event listener for the click event. And upon a click, I want to call add and I want to use my two inputs here. So we'll actually use an anonymous function here, a little arrow function here simply. And in there, I will get the two concrete values the user entered into these inputs and then call add with those values. So num1 here simply is num1 input dot value. And you already see I didn't get auto-completion here, and I do get an error here in my IDE, even though this should work, right? We are selecting input element here. So not sure where this is coming from. We'll fix it later. For now, let's live with the error, and let's also extract num2 from num2 input. Then we can calculate the result by calling add, by passing in num1 and num2. And then last but not least, we can call print result and pass in the result. Now, we have errors here, but let's try running this code. So I will compile app.ts, and of course we get errors here, because we get the same errors my IDE already detected. But as I mentioned earlier, the file, the JS file, is still generated. So we do get this file here. Hence, if we go to the running application and I reload, I got these two inputs, and I can enter my two values and click add, and it does something. Now, we are looking at an old bug again, though. The two values got concatenated instead of added. Now, this is not really what we wanted, right? And why do we get this? I think we got rid of that when we introduced types. So why do we have that error again? Well, keep in mind that types can help us, but only if we really use them. And here we clearly have an error. So TypeScript doesn't really understand that we have a value property on num1 input. And if we take a closer look, it therefore, of course, also doesn't know what's inside of value. So num1 effectively is of type any, and we pass that into add, and indeed add expects two numbers, but it turns out, since num1 is any, TypeScript trusts us, maybe that is a number, so it doesn't complain here, also because we already got an error here, so TypeScript kind of gives up, and allows us to pass in values which seem to be strings. Okay. Well, maybe let's resolve this error first. Why does TypeScript not understand that there is a value property on num1 input? We are selecting elements in the DOM here, and we know these will be input elements, and of course they therefore have a value property. And indeed, this part is not failing, our code is working here. So why does TypeScript not understand that these are inputs? Well, how would it? We only tell TypeScript that we select an element in the DOM by ID. But this could be any element. You can have any ID on any element. It could be a paragraph, it could be a button, it could be a list item. It doesn't have to be an input element. And therefore, if we hover over getElementById, we indeed see that TypeScript only infers that this is of type HTML element. And that's of course very unspecific. It just means any HTML element, not specifically an input element. Now, we of course know, as a developer, that we will get an input element here. And by the way, TypeScript doesn't scan our index.html file to check what we're selecting there. So we can't rely on type inference here. Instead, we can do something which is known as typecasting. We can override the inference made by TypeScript. We can tell TypeScript that this will be of a different type. Now you could think we do this by adding a type here. And here we could use the HTML input element type. You might not know this type, it's one of the built-in types for working with the DOM, and this basically says what I store in here has to be not any HTML element, but an HTML input element. But of course you see we get an error here. And we get an error here because just because we want to store such an element here doesn't change the way getElementById works. TypeScript still doesn't know what we get here. So instead we'll use this typecasting thing I mentioned. You do that by adding the as keyword after the thing where TypeScript infers some type which you want to change, and then you set the type you want to use instead of the type TypeScript inferred. So in this case, HTML input element. Now this is pure TypeScript syntax. This will all be lost once we convert it to JavaScript. But this now overrides what TypeScript uses or infers here. If we now hover over num1 input, we see what's stored in there is a HTML input element. And if we scroll down, we see that therefore for num1 input, we don't get this error anymore. We now know, okay, yeah, this is now clearly available. This property exists. We get a new error, to which I'll come back later, but this error is gone. So this is typecasting in action. There also is another syntax you can use. You can use angle brackets in front of the thing you want to cast instead of after it, as we do it with as, and then use the type here. Both works. This syntax is a bit more common now, but both does the same thing in the end. With that, we're simply overwriting the type TypeScript inferred. And I'll leave both syntaxes here to show you both. Of course, in your apps, you should be consistent and typically use either of the two. So now the errors down there are gone, but we got a new error here. And that error now makes sense. It's important to understand that the value property on an input element always returns a string, no matter which type this input is of. So even if you set this to type number here, this doesn't change the type of value you get from the value prop. And it also does not change with the value the user entered. If a user enters the number 10 into an input, it's still a string. It's wrapped into quotes, so to say. Value always gives you a string. So num1 and num2 are strings. And therefore, we are now calling add with two strings. And that's what TypeScript is not liking here. If we would compile this file, we would get errors where we clearly learn that type string is not allowed here, but that we want the type number instead. So to change this, we now need to parse these strings to numbers. So we can add a plus in front of both value retrievals here to cast the string into a number. Now that of course means that if anything which can't be cast is entered, this will be converted into not a number, but that's fine for now. And with that, we again see the power of TypeScript in action. By being clear about the types we're working with, we can catch this nasty bug we introduced where we forgot to cast the values and where we hence concatenated the two values instead of adding them mathematically. So now with that, if we save this and we compile this, we can reload this page, and now if I enter the two numbers here, we get the addition in a mathematical sense instead of the concatenated strings. So this is how we work with types and some of the core types we can work with. Now, of course, you can learn about all types in the official docs here in the handbook, but we will also have a look at some other core types and features throughout this module. So let's continue. So we saw some core types in action, we saw typecasting in action. Now, let's dive into the a bit more advanced types. Objects and arrays, for example. Now, thus far, I only work with strings and numbers, and yeah, actually, HTML input element is an object in the end, just a specific type of object. But let's have a look at objects in general. Let's say, for whatever reason, when we calculate our result here, we don't want to store that in a constant result like this, or not just in that constant, but instead we also want to create a result container, and that should be a JavaScript object where we have the res property, and that holds our result. Now, of course, it's a bit redundant to have this extra container, but for demo purposes, it's fine. Now clearly we have an object here. Now in this object we have one property, the res property. Now which type is result container now? Well, it is of type object. If I add object here, this works. I can explicitly set this to type object and TypeScript won't complain. Now, one problem with this approach is that we don't get the best possible auto-completion and type support. If I access .res here, I get an error, and if I access anything else here, I also get an error. Now, for H that makes sense, but res should definitely work, right? Because we have a res property here. Well, the object type is very general. It just says it's an object, but I have no information about it. So that's not really the type we want to use day to day. Instead, we want to be specific, and you can define an object type in way more detail in TypeScript. Instead of using object here, you can use curly braces here in the type assignment. And this might look strange at first, because it looks like we are creating an object here. But keep in mind, we're on the left side of the equal sign here, and we're after a colon. So this in the end just defines a type. And this is just us defining an object type, because we can now define all the key value pairs we have in this object. For example, we can say this object will have a res property, and the type of this res property, so the value stored in the res property, will be a number. And now we're making it very clear what's inside result container. So now I can access .res here, and I can do stuff with it that I can do with numbers. But I can't access to .h, for example, because there clearly is no h property defined in this object type. Now, of course, you can do that, but it's redundant, because if we remove that, we see that's the type TypeScript inferred anyways. Because again, we can rely on TypeScript's type inference, and if we initialize an object with a specific value, then of course TypeScript infers the object type to fit that value's structure. So here, since I initialize result container with an object that has a res property which holds a number, TypeScript correctly infers that the type of result container is an object type with a res property which holds a value of type number. So we don't need to set it explicitly. I will still do it though to have this for reference, but you wouldn't do it in reality because TypeScript's inference does its job here. Now let's take it to the next level. Now let's say we want to store all the result containers in an array now. So here we could have a results array, and now for every time we click the add button, we reach out to results and we push result container into results. And then we log, let's say, the results array here. If we do that and we quickly compile this code, let's see what this gives us. If we reload this page and I add two numbers, you see now I got an array with one element, which is an object, which has that res property and the result. And if I now add a second calculation, we got two entries here with these two objects. So this works as intended, but we can add anything to results here. If I also add, let's say, the number 5 here, this will also work. Now, maybe that is what you need in your app, but in most cases, it's probably not what you want. Now, the problem is that I initialize results here, and I make it clear that it will be an array, but I'm not specifying which kind of array, which kind of data will be in the array. And in JavaScript, of course, you can have mixed data, and as I said, sometimes you need that, but also a lot of the times, you don't need that, and you want to have one data type in an array. Now you can tell TypeScript which data type that should be. So let's assign a type here. And in this case, I want to have a collection of objects in this array. And the objects should have this structure here. So in that case, I can add this as a type. But now I would say that results should be an object of that type. But it should be an array holding such objects. And we make that clear in TypeScript by adding square brackets here. And with that, we're saying, okay, this is an array, and the data types in the array will be objects of that structure. And now you see I get an error down there where I try to push 5, because 5 is not assignable to a parameter of type object which has this structure. So now again, we avoid an unnecessary mistake by being clear about the types of data we store. And just a side note, of course, if we had, let's say, an array names here, which we initialize with a value, then TypeScript would automatically infer the array. Here it infers that this is an array full of strings. So that is something we can also rely on. And we can also turn this in a const, by the way. So that is something we can rely on, and this is just needed here if we initialize this with no array or with an empty array, and we want to be clear about the types of data we can add. Now with that, let's take our object here to the next level though. In here, I now want to also have a function print. So I want to have a method to be precise, because a function in an object is called a method. We can do that by adding print like this. And in there, I just want to console log this res. Now I get an error here. I get an error that I can't add a print method here because, well, I clearly defined that my object will only have one property, res, which is a number. It won't have a print property which holds a function. So maybe we should extend our function type here, or simply get rid of it here and use inference. Now this works here. And surprisingly, this also works. I can push this to my array, even though in the array I say nothing about this function here. Well, that is how TypeScript simply behaves here. It doesn't really see this as a problem that we have more properties than as I defined here. It's just happy that it gets an object which at least has this res property. It doesn't care that we have more properties. Still, we could be more specific up there and make it clear that any objects that go into that array should have a print method. And for that, we now have a new question to answer. How do we define that there should be a function in print which has certain types for its possible parameters and certain return types? Well, we assign a type to print and we use a so-called function type here. This looks like an arrow function here. We have a list of parameters and then an arrow. But again, just as with the object here on the left side of the equal sign, this is not a new function we create. Instead, we're just defining the type of a function that will eventually be stored in print. And here I want to have a function which returns nothing, so which has a return type of void, and which takes no parameters. And if it would take parameters, we could simply add them here, but the print function doesn't need any. So with that, I am making it clear that in results, we have an array of objects where every object has a res property, which is of type number, and a print property, which actually holds a function, which takes no parameters, and which returns nothing. And with that, I can, for example, call results0.print here like this, and it should just work. So let's try to compile this, and it does compile without errors. And if I now reload, you see indeed it prints 10 here, and that is coming from this line here. So that's really, really nice and useful. And this is how we can work with objects, arrays, and functions, and how we can work with their types. Now let's see which other types TypeScript has that we should be aware of. Let me introduce you to a TypeScript feature that can help us simplify lines like this. In this line, we have a very long type assignment, as you can tell. This is all just defining the type of data stored in results. Now, of course, that's okay, we can do that. But maybe we want to make it a bit easier. Well, in such a case, we can use a so-called type alias. We do all of that by adding the type keyword, which is also only known to TypeScript, not to JavaScript, and thereafter any name of our choice, which typically starts with a capital character. For example, calculation results. Now this effectively allows us to create our own type. Now with the equal sign, we now define the type of data on the right side. So we'll cut it down there and add this here. Now this can be deceiving because now the object and the array is on the right side of the equal sign, but keep in mind that with the type keyword, this is a pure TypeScript feature. This is in the end just telling TypeScript, hey, I got my own type, named calculation results, and it in the end is this type. And now we can use calculation result down there. And with that, we simply outsource this long type assignment into this line. And one advantage is that if we now use this in other places of the code as well, which we don't do here, but which we could again use the same alias, and we wouldn't have to repeat this long type everywhere. So type aliases can make it easier for you to manage your own complex types and write them only once and then use them in different places of your application. Another neat feature TypeScript offers are literal types and union types. Let's start with literal types, and for this I'll come back to print result. There we get the result. Now let's say we also get a second parameter, print mode, and that should be one of two allowed values, either console or alert. So we could pass in a string here, and then here we check if print mode is equal to, let's say, console, and if that's true, I will console log the result. Else if print mode is equal to alert, let's say, I will show an alert with the result. And for any other value, I will not do anything. That is something we could have here. And now if I go down to line 39, and instead of using my print method, I again use print result, I could pass in my result from there, so not the result container, but just the result, and then maybe pass in console here, and repeat the same with alert. And now with that, of course, if we compile this code here, and we reload, and I enter two values here, I get 10 in the console, but also here as an alert, because I called it with both modes. That could be a typical use case, maybe not with logging, but in other scenarios, like signing up a user, where you either have the login mode or the sign up mode. So actually, we're not interested in any string here, we're just interested in these two concrete values. And for that, you can use the literal types. Instead of just using string here, you can be more specific, and you can say, I want to allow the value console or alert. And this is now, by the way, a combination of multiple TypeScript features. This here is a literal type. If you don't just have the overarching type, but a concrete value for that type. So here a concrete string. And if we combine multiple types and we allow multiple types for one parameter or one variable, we have a so-called union type, indicated by this pipe symbol. This creates a union type, which means multiple types of values are allowed, in this case for this parameter, either this literal type or this literal type. Any other string will not be allowed. The advantage is that now for one, we get better auto-completion here in the IDE, as you can see. And if I try to call this with, let's say, any other value, I get an error, because this is not allowed here in my union type of literal types. So literal types and union types are other very important features in TypeScript that allow us to write cleaner code. And of course, we can also use them in conjunction with a type alias. We could create our new custom type alias here and name it print mode and say it's console or alert. And then we could use this here and anywhere else where we want to allow these two types. So that's also something we can use type aliases for, but even without type aliases, literal types combined with union types are extremely useful. And union types, of course, can be used with any types. You could also accept, let's say, here, a string or a number as a result you want to print. That's another use case of union types, not just with literal types, but also with the main types TypeScript supports. So these are more TypeScript features you should be aware of when you're working with TypeScript, since they can simplify your life as a TypeScript developer. Now, I know we're moving fast here, and you're learning a lot about the different types TypeScript offers. Now, you don't have to remember them all, of course. Using them comes with experience, and if you, for example, use a string instead of the more precise literal types combined with that union type feature, that's also not the end of the world here. The official docs, as well as dedicated courses like my Understanding TypeScript course, can help you dive deeper into TypeScript and get more accustomed to it. And you can also always treat TypeScript as an addition. You can write your regular JavaScript code and enhance it in some places with TypeScript syntax where you need that extra type support and where you want that extra type safety. Now, speaking of that, let me add more features TypeScript adds, or let me show you more features TypeScript adds. We learned about union types and literal types. Now, when you have a situation like this in your code, where you accept two possible values, using a string is of course absolutely fine. You can solve the problem like this. But you can also use another type introduced by TypeScript, which is the enum type. This does exist in some other programming languages. In JavaScript, it does not exist. An enum type is created by using the enum keyword, and then any type name of your choice, which, just like the type alias here, should start with a capital character. For example, in this case, output mode. Now then you don't use an equal sign though, but instead curly braces. Now it looks like we're creating an object here, but this is just the enum type syntax. Between the curly braces, you now enter all the values you want to allow. And typically here, you use all caps names like console and then with a comma, alert. Now this might look strange. What is this doing? This basically creates an, you could say, array of choices you can use in your code. And here, for example, instead of print mode, we could now use output mode. And here, check not for console, but for output mode dot console. And here, for output mode dot alert. And of course, now when we call print result, we also have to pass in output mode dot console and output mode dot alert. Now this simply is an alternative to using the string literal union types. You can of course use either of the two approaches. This here behind the scenes will be stored as numbers, which just are encoded to human readable values here in your TypeScript code. Behind the scenes this will be the number 0, this will be the number 1. And you can see this if you compile the code to JavaScript. If we do that and we have a look at the JavaScript file, we see this looks quite complex, but in the end, output mode is just an object which has properties console and alert, which store numbers 0 and 1. So that's behind the scenes stuff. In front of the scenes in our code, we simply use this with a dot then to access our concrete values. And that's an alternative to using string literals with a union type simply. So that's an enum, something you can use if you have multiple choices you want to use in your code, multiple modes or something like this, then you can always use an enum. And with that, I basically want to wrap up these core types introduced and added by TypeScript, and instead now have a look at some advanced types or other important TypeScript features, namely classes and interfaces. Now in JavaScript, we can work with classes to define blueprints for objects, right? And of course, we can use classes in TypeScript as well. It supports this feature as well. And since it compiles code to code that works in older browsers as well, it even compiles class code down to JavaScript code that does not use classes but constructor functions and runs in older browsers as well. Now let's stick to this file and let's say in there, maybe at the very top, but that does not matter, we want to define a class for a user in our app. Now this is how we can define a class. And now in this class, we can add a constructor function. We can expect a name, which is of type string, and an age, which is of type number, let's say. And then here we say this name equals name, and this age equals age. And now we would have these two properties here in our class. And already we get an error. Property name does not exist on type user. Now in vanilla JavaScript, this would be a valid syntax we could use. Not so in TypeScript. Instead there, we have to add property as fields all the time, every time we want to work with a property. In JavaScript, the field syntax is pretty new and experimental and not supported by all browsers. But since TypeScript gets compiled down to JavaScript code, which will work in all browsers, TypeScript can enforce certain features which wouldn't work in browsers otherwise. And here we have to simply add name and age as fields up there so that we can work with them in here in the constructor. this is just how TypeScript works. It forces us to use this setup because this, in the end, just leads to cleaner code. Other developers reading our code can quickly see which fields, which properties this user class will have. Of course, for this simple class, it wouldn't have been too hard by just looking at the constructor. But if this is a bigger class with a lot of properties that get added everywhere throughout the class, having a list of properties right at the top can be very readable and very helpful. So that's how we can define such a class in TypeScript. Now, in addition, TypeScript also gives us access modifiers. We can make it clear whether a property is intended to be used from only inside the class or also from outside of it. And there, for example, we could lock down the age to be used from only inside by adding private. The opposite is public, but you don't need to add this because it's the default anyways. So you can add it, but you don't have to. Now, age is really only usable from inside this class. If I create a user here with new user and I feed in max and 30, I can console log user dot name, but if I try to access .age, I get an error. Now, technically, JavaScript, of course, doesn't really have private properties, or at least it's a very new feature which is not supported everywhere. So technically, once this is compiled to JavaScript, this privateness is lost. It's just a TypeScript feature, so that in your TypeScript code, you can't access this and you get an error, so that developers writing code know, okay, I shouldn't access this property. This code is not the code I should write. That's the idea here. Using the name is fine because that is public, of course. And now there also is a little shortcut in TypeScript. We can set up our class like this, but I'll copy it here and comment it out, because for this common scenario where you have a couple of fields and then you assign values to them in the constructor, you can shorten this and actually get rid of these fields and instead add the access modifiers here in front of the parameters in the constructor. And that's simply a special feature available in the constructor of a class. By doing this, you tell TypeScript these parameters should also be automatically converted to properties of this class. And therefore, we can also get rid of these lines. So this class will do exactly the same thing as this class did, simply because of this shorthand TypeScript supports to you. This makes it clear that TypeScript should add a name property to this class and an age property, and the value passed in for the name parameter should be stored in the name property. The value passed in for the age parameter should be stored in the age property, and the name property will be public, the age property will be private. So the same thing we have up there, but a bit easier. That's a huge advantage. So this is how we can work with a class here. Now, of course, in TypeScript, just as in vanilla JavaScript, we can also inherit. We can add an admin class, which extends the user class, let's say, and this now simply allows us to add additional fields. For example, here in the constructor, we could also have a private or public, whatever you want, property named permissions, and this, let's say, is an array of strings, whatever you want. And now we just have to call super in here, and therefore also accept a name here and a age. In this case, without using the shortcut, because I will forward name and age to the super constructor, so of the base class, and also add my own property here, this private permissions property, which holds an array of strings. So this is how we can extend a class, how we can still use this shortcut and call super, which we do have to do if we extend a base class and bring our own constructor. And now we can, of course, work with either that class or that class, just the way you are used to from vanilla JavaScript classes in the end. Now, kind of related to classes, but also different, is a TypeScript exclusive feature called interfaces. Now, when you define a class, you have a blueprint for an object, right? And you can always instantiate a class as we're doing it down there. Now, sometimes you just want a blueprint, but you don't want to instantiate it because it's very simple, it doesn't have any methods, and you just don't want to call new and create an object like this, but create it with the curly braces and still have that extra type safety. Now, in such a scenario, you can of course use an alias. Here, for example, I do store an object in there, but you could also use an interface. An interface may be named calculation container here. You create it with the interface keyword, then any name of your choice, which should start with a capital character, just as for custom types and classes. And in there, you could define how an object should look like. That you have a res property, which is a number, and then maybe also a print method, which returns nothing. This is how you then define it here. You could also use this syntax if you wanted to, but I will go for the method syntax. So now this is an interface, and we can't use new with it. New with calculation container will not work, but we can use it as a type. For example, here we can use the calculation container and have an array of calculation containers. And our other code will work because we define in there we want to have an object with this structure, and that's exactly what we create down there. So you can use this as a blueprint for objects which you create with curly braces instead of with the new keyword. But like this, it's simply just an alternative to the type keyword, because this is basically the same as if we would have said type calculation container equals this. This is also something we could have done. So why do we have interfaces if they're just an alternative to the type keyword? Well, besides using them for object type definitions, you can also use them as contracts in classes. What do you mean by that? Well, we can define an interface, maybe name it greetable, where we say we want to have a name which is of type string. And now in our class, we can do something which is called implement the interface. And that's a pure TypeScript feature. This does not exist in vanilla JavaScript. Now, what does this do? It forces this user class to have a public name property which is of type string. And if I would remove this here, this parameter property assignment, I correctly would get an error that the class user incorrectly implements the interface greetable. That's why I refer to interfaces also as contracts. Besides using them as blueprints for objects, you can also use them to force classes to have a certain structure to bring certain properties. Classes can then always add more than what the interface demands, but never less. And you might wonder, why would you do that? You are the developer, you are writing the code. Why would you force yourself to build a class in a certain way? If you want to do that, you can just do that. Well, for one, keep in mind if you're working in bigger projects, it can be hard to keep track of what you want to do where. Also, if you're working in a team, it can be helpful to force other developers to do something in a certain way so that you all use the same style and you're working on the same goal. And here, it might get clearer if we maybe create another interface, printable. You don't have to name it like this, but that's a convention you will often see. And there you say that you want to have a print method, then you could implement this as well. You can implement multiple interfaces by simply separating them with a comma. And now you would be forced to add a print method here, which does something. We don't know what, but it does something. Now we can make it clear that every class which has a printable interface, that implements a printable interface, needs to have a print method. And this can give us extra type safety, because maybe we got another part in our code where we're not interested in the exact type of object we're working with. We're not interested in the fact whether it's a user or an admin or a horse, but we are interested in the fact that we can call print. In such a scenario, we could simply assign the type printable to the parameter or variable that stores our object, and it would be clear that whatever is stored in there will have a print method which we can call. So this is why we can use interfaces as contracts to give us extra type safety and guarantee that certain classes, and therefore the objects built on those classes, have a certain structure, have certain methods. And it is something you will also see a lot when you're working with TypeScript. Now, I do want to emphasize that if you compile this file, interfaces are totally lost. We see a lot of code here because it was compiled to code that doesn't use the class keyword. Hence, we don't see the class keyword here, but we won't see the interface here. So this is a pure TypeScript feature which gives us extra type safety whilst we're working in TypeScript. Now with that, we're nearing the end, and there is just one more type I also want to introduce, or one TypeScript feature I want to introduce, and that's the generic types feature. Now what's that? Well, we already are working with one generic type here. If we have a look at our results here, we see this is an array full of calculation containers. Now, array turns out to be a type in TypeScript, which is a so-called generic type. We could say that results is of type array here. But TypeScript wouldn't like this, as you see. It tells us that the generic type array T, whatever that is, requires one type argument. There are certain values in JavaScript as well as in TypeScript, therefore, that simply work together with other value types and other values. And the array is such a value. The array itself is a value. Any array is an object. But an array, of course, only really works because it stores other values. So we got two types work together, the array and the data in the array. And therefore, we want to be clear that results holds an array, but we also want to be clear about which array. Now we could say array any, and use these strange angle brackets to connect these two types. We have an array, and what's in the array is anything. But we can also be more precise and say it's an array of calculation containers. And in the end, what we used before, calculation container with squared brackets thereafter, is just syntactic sugar for this notation here, where we use the generic array type to be very precise about the type of data inside of it. And there are other generic types in TypeScript as well. For example, the promise type. If you have a promise, for example, because you're using the fetch API to make a HTTP request, then of course you have a promise as a return type, but that promise will eventually resolve a value. And that value will also be of a type. So a promise is another example of two types working together. We have the promise type, and the promise will give us another type of data. Therefore, promise is another generic type in TypeScript. Just like array, it's the combination of multiple types. And you can also build your own generic types if you have something like this. If we have a very simple dummy function, maybe at the very bottom here, log and echo, which doesn't do much, but which gets a value and which then logs the value and returns it. Then this could be a generic function. Now here we accept any type of data, you could say, but then we don't get any extra TypeScript support. If I call log and echo and pass in hi there, then I know log and echo returns what I passed in there, and that's a string. So I would like to do string stuff with it, like split it. But I can't do that. Why can't I do that? Because TypeScript doesn't know what log and echo returns. It returns anything because I set the value type to anything here. So that's where generic types can help us. We can create a generic function in this case. You can also have generic classes and objects, but here we can build a generic function. We do that by adding angle brackets after log and echo, so before the parameter list. And then typically you use T as a placeholder for the type, but you can use any identifier you want, but T is what you'd see most often. And then you say val is also of type T. And what you're saying with that is whoever calls log and echo should give me the exact type of data he wants to work with, and then I know that I will get an argument of this type. And you can use that generic type anywhere in the function, either for the parameters or inside of that function body, wherever you need it. And here, when I call log and echo, I can now make it clear that I pass in a string here, and now I get nice auto-completion if I, for example, want to split the result or whatever I want to do. So that's how I can build my own generic function in this case. Now, Now, as I said, you can also build your own generic classes and so on, but this would now lead a bit too far. There is way more you can do with TypeScript, but this is only meant to be an introduction which gets you to think about TypeScript and gets you introduced to some of the core features which you then will see throughout other projects you're working on, or which you will then see once you dive deeply into TypeScript. So these are generic types. They're everywhere. There are built-in generic types like array and promise, and you can also build your own ones. Now, to come to an end, let's actually leave this code file and talk a bit briefly about the compiler. Thus far, I always compile the file by typing tsc and then the file name. Now, that's a bit cumbersome. Now, actually, we can enter watch mode by adding -w thereafter. Now it compiles, but it keeps on watching that file. And whenever I change something in there, it recompiles it automatically. Now, that's better. But I'll quit this with Ctrl+C because it might still not be everything we want. Sometimes you also have multiple TypeScript files in a project and you want to compile them all simultaneously. For example, we have other TS, and in there I console log hello, which doesn't really use any TypeScript features, but which still might be a TypeScript file I want to compile as well. For now, I have to type tsc app.ts and tsc other.ts if I want to compile both, and that's cumbersome. Well, we can turn this into a TypeScript managed project by running tsc --init. What this does is it creates a tsconfig.json file, at which we'll have a look in a second. But even without looking at the file, we now can do something different. We can run just tsc without any file name we point at, and also tsc-w. Both is possible. When we run either of the two, what now happens, all TypeScript files get compiled. Now you see I now get an error here, and I will come back to why we get this in a second. We didn't get it before, now we get it. Again, I will come back to that. But it will compile all files. And I can prove that by deleting the two JavaScript files and running it again. Now you see it created the two files. So now we can compile all TypeScript files simultaneously, and we can also watch all of them simultaneously with -w. But why am I getting an error now? Object is possibly null. We didn't get that before. Well, because the tsconfig.json file allows us to configure the compiler now. And the default configuration, which was generated here, is a different one than what we had for the tsc command without that file before. Now you see, there are loads of options in there. Most of them are commented out, and you find short descriptions here on the right. In my Understanding TypeScript course here on Udemy, I walk through all of that in way more detail. Here, for example, you can control to which target you're compiling. And if you set this, for example, to ES6, classes will not be converted to non-class code, which works in older browsers, but you will end up with ES6 JavaScript code, which therefore only works in browsers that support ES6. So that's how you can control which JavaScript code is produced. But you also have another setting here, the strict setting, and this controls how strict the TypeScript compiler is. And that's what's responsible for this error in the end. Before, the compiler was not that strict. Now it effectively turned on all these options here, which checks different things in our code. For example, it checks whether something could potentially be null and could lead to unexpected errors. And in app.ts we have such a case. When I get access to my button here, and also to the inputs, what I get here could be null. Now here I use typecasting, so I make it clear to TypeScript that this will not be null, but an HTML input element. Here, however, I rely on inference. Now TypeScript infers that since I use the button tag selector, this is a HTML button element, or, with a union type here, it could also be null. Because if I have no button in my HTML file, I can't select one. So this could be null. And before, TypeScript didn't care about this. With the strict mode here, it now does. Now we can either turn this on or simply not use this general strict rule, but only turn on the strictness checks we want. But here I will leave it on and show you how to work around this issue. It's very simple. We could either add a if check and check if not button element, so if this is falsy, and if that's the case, we do something, or we only add an event listener if it's truthy. So that's one thing. We could add an if check. Or if we know with certainty that the button will exist, we can add an exclamation mark thereafter, which is also a TypeScript feature, not a vanilla JavaScript feature, which tells TypeScript, this will never be null, ignore the null case. And now our error would be gone. So that's another TypeScript feature which can be useful, especially if you get the strict options turned on. And now there is more you can configure here, and going through all of that would really bloat this module and be too much for this introductory module. If you want to learn more about TypeScript and about this file, my TypeScript course, or of course the official docs, are the place to go.